Hi, this is Codeforces question, Hamiltonian Wall. So you are given two string, S1 represent first row in grid and S2 represent the second row. Every string contains characters and each character represent color. We have only white and black, so W means white, B mean black. So here we have for S1, then first row, the first character is W, means this is white, then B black, then black. For the second string, represent the second row, first character is black, the second character is black, the third one is white. So we need to find a path in this grid that meets these three conditions. The first one is for each I, xi, yi, and xi plus 1, yi plus 1 share a common side. And that means if you want to go from this cell to this cell, this is valid, and that because these two cells shared a common side, which is this one. And also if you want to go from this cell to this cell, this is also valid because both of these two cells share this common side. While you cannot go from this cell, the path directly to this cell, because these two cells does not share a common side. The second condition is all black cells appear in the path exactly once. So all black cells, that means that you have to cover all the cells on the grid, all the black cells, and in the path every cell should exactly appear once. So if you come from this node to this node, you cannot return back to the same node, or if you come from this node to this node, you cannot return back to the same node again. The third condition is white cell does not appear in the path. That means that you cannot start from this node because it's white, or you cannot do this because this is white, or this is white. So, and in the question it's given that every column at least has one black cell, and you need to find the path that meets all these three conditions. So for this example, you can do this, and we covered all black cells and everyone have occurred only once in the path. And as you can see, every two successive node shares a side, common side, and there is no white cell in the path. So you should print yes for this example. For this one, if you start like this, now if you do this, you miss this cell and you cannot go back. And if you do this again, you cannot back to this cell to continue the path. So for this one you have to print no. For this one also, if you start like this, trying to cover all the node, so here you cannot go to the right because it's white, and you cannot return back here because it's black. So also for this one the answer should be no. For this grid you can do this path, and this path meets all the conditions and cover all the black cell. This is why you have to print yes. So how can we solve this problem? To do that, first of all, we need to count all the number of black cells in the grid by iterating over the two strings. So let's call the variable total number of black cells equal, in this case we have P 1 2 3 4 5 6 7 8 9 10. We just loop over two string and count the total number of black cells. Then the second thing we need to do is we will start our path from left and we will go to the right, and we will do two traversal, one from the first black cell, this one, and if the answer is no, we need to check by starting from this cell, and for every cell we will have last I, initially it's -1, and last j, initially it's -1, and we have the current I equal 0 for this cell. We will start from this cell, so I mean the row 0 and the column equal 0. So, and we have a counter here, initially equal 0. So here we start, this is black cell, so we increase our counter to 1. Then we check if the last I, because our current I is 0, we need to check if the last I was 1, and if we were here, that means that this node was visited and we cannot go down, we have to go right, but again the right is white. And remember also here the last j is not 1, it's -1, and that means that this node is not visited, and we have to go down. So first of all, we need to cover both cells in the same column, and coming here, first of all we need to update our count. So now we have 2 black cells in the path, and we need to update the last I and last j with I and j. So the last I, which is in this cell, was 0, and the last j in this cell is 0. Now for the current one, I equal the row is 1 and j is 0. Then again we need to check the last I. If it's 0, in this case it's 0, that means that this node in the top is visited. Then we don't have other choice other than go right, but before that we need to check if the right is white. If it's white, we break. If it's black, we continue. So we continue because it's black, and coming here we increase the counter of black cells. So now we have 3 cells, and we update our last I, last j by the value of I and j, 1 0. And for the current, we need to update the ij for this cell. This cell I equal 1 and j equal 1. Then for while we are here, we need to check the last I, the last I and last j. So last I is 1. Last I was 1, which is here, and last j is 0, which is here, and that means that we have two options, either to go to up or to go to the right, because the cell in the top was not visited, but it's white, so we cannot visit this cell, and we have to go to the right. If it's black, it is black, so we go to the right, and we increase our counter, it's 4. We update last I and last j by the values of ij 1 1, and this I here is 1, j equal 0 1 2, and here again we need to check the last I if it's 0, because here the current I is 1. We need to check 0 to check if it's visited or not. So last I is 1, and that means that 0, the 0 1 is not visited, so we have to go up, increase the counter, and we update the last I, the last j 1 2, and here I become current I is 0. Now here we check again for the last I. The last I was 1, and that means that this node is visited, and here we don't have other option other than going to the right cell, and this is black, so 6. We update this to 0 2, and this is 0 3. Now again here we need to check, because we are at 0, we will check the I equal 1 with the same j. It's if by checking the last I, and we know that the last I was 0, and that means that we came from this node, not from this one, so that this one is not visited. We have to go down. This is 7, this is 0 3, and the current one is 1 3, and here we need to check if the last I was 0. It is 0, then we have no option other than going to the right, and the counter is 8. Then from here counter is 9, then we go up, counter is 10, and while iterating we compare, or when we finished we check if 10 equal to this value, which is 10, and this is why we have a path, and we need to return the value yes. So let's solve it for this example. For this example, we start with current I equals 0, j equal 0, and last I equal minus 1, last j equal minus 1. Then we move here, we have to cover all the node in the column, so our counter become 1. Then we have to go to the right, the counter become 2. Then here we need to check if this cell is covered, but this is white, we cannot go, so we have to go to this one, counter become 3. Then from this one we need to check if the cell in the same column is covered. It's not, by checking last I last j. So we come here, counter is 4. Now we need to check the same cell. So the same cell in the same column is visited, so we cannot go down, and the only option is to go right, but right is white, so we have to stop our function, and the value is 4, while the total number of black cell is 1 2 3 4 5 6 7 8, and this path return no. Then we have to check for the other path. We start from here, then we go here, then here we need to stop, then again the counter does not equal to the total number of black cell, so the final return value should be no. Let's look into the code implementation. So here is our input, and we call the solve function that take s1, s2, and m, which is the number of the column or the length of the string. Then, as we said, we have to start either from this one, then from this one, and dfs is our function that do the traverse. And here we have last I, last j, we have the current I, the current j, and the count, which is initially 0, and last I, last j are -1 initially. And here we check if I equal 0, then we are at the first row, and that means that we need to check the last I. If last I was 1, that means that the same node in the same column was visited, and we don't have option other than going to the right. So this is to go to the right, but we go only right if the right cell is black. Then if the last I was 0, then that means that we came from the same cell. So if we are here, it means that we came from this cell, then we have to go down. So this is why here we need to check the this cell. If it's black, we need to go down. We pass I equal 1 with the same j. Else, if it's not black, if this one is white, then the other option is to go directly to the right. So we need to go to the right if the right is black, and we will do the same for if we are not in the first row. It means we are in the second row, we need to do the same checks.